I'm ready.
Good up. We should be live now. Let's just see. Going live, going live, going live. There we go, it says you're live. Hello everyone. Today I'm joined by Brian E. And we're discussing a topic and it's related to objectivism in a way. It's the idea that the concept of an actual infinity is a floating abstraction. I think it would be useful to go over my case for what I mean by that first, and then you can kind of like attack it if you want. Does that sound good with you?
That sounds good with me.
Alright, cool. Just right off the bat, do you have like anything, any like things you want to shout out or whatever? Like let people know who you are.
I am Brian. I'm usually a programmer. I like math a lot. Uh, I was recently introduced to debating and philosophies and governments as a whole. And this has only been like a month. I've been just talking about this stuff, and I am learning so much, and it's very exciting to learn so much in the short time.
Brilliant. Yeah. So basically, the idea with this is it's related to a distinction Aristotle made between what he calls a potential and what he calls an actual. So let's take the example of a little acorn, which could grow up into being an oak tree, right? So this acorn, it's an actual acorn. That is the actual thing that it is. But it is a potential oak tree. It could become an oak tree. So the point made by objectivism, and in fact, actually this goes back to Aristotle, he made the same point, is that you couldn't have any actual infinity. You couldn't have anything which actually exists and have it be infinite in any respect. There is a legitimate way to use infinity, and that's to say there are infinite numbers, right? What that means, if you're using it precisely, is to say, I could keep counting 1, 2, 3, 4, etc. forever. I'm never going to run out. But that is referring to a potential. I could keep listing off further and further numbers. But those numbers aren't actual until I get to them in my listing, right?
Mm-hmm. So, when when I talk about infinity, I have a similar definition when it comes to counting up, right? You will never reach any infinity if you just count up. But in a mathematical sense, you can still walk an infinite distance if you're given an infinite time because of how multiplication rules work. And when I say like, this is a potential in that I don't have proof that this would be possible, but my position is that there is no rule of physics that says it's impossible. Meaning that stating that it is impossible would be yeah, I don't I think there would be some proof needed there, right? Though I do think there's a different definition of infinity that we have in that if infinity is a specific number or not, right? And what kind of specific it is. Because the infinities I'm talking about is a kind of infinity where if you do well, I call this infinity omega. It's in infinitesimals in math, right? If you do omega plus 1, then that is larger than omega. So these kinds of infinities still have an order in them. They and it means that they are still well defined and they have identity. So they don't break. What's it called? Yeah, identity. So they could be well defined.
Sure. So I'll just deal with that first point first. Under mathematics, it's perfectly fine to, come up with these. I wouldn't say fine. But you know, it's you're not gonna open up a black hole or whatever if you start multiplying infinities or whatever and saying, "Oh, Jane walked an infinite distance. She took an infinite time to do it." Like whatever. You're just manipulating symbols. But I don't think that could ever correspond to reality. And you were asking for like a sort of law of physics, which would prevent that. I think it's actually more fundamental. There's a law of metaphysics that would prevent this. Because to walk some distance in some amount of time, those would have to be specific quantities. A specific quantity of distance, of length, and a specific quantity of time, right? Or else it can't be actual. So this ties into what it means to say infinity. Infinity doesn't just mean very, very, very big, right? It means larger than any specific quantity, which means it's no quantity in particular. It's larger than all of them, right? Then you have to have, for an actual specific quantity. But infinity can't be a specific quantity because it's larger than any specific quantity, right? So which means it's not any specific quantity. The same goes for an infinitesimal, right? The little epsilon that you might use in calculus, or whatever.
Yes.
That would be smaller than any specific quantity, or closer to zero than any specific quantity, but not zero. That means it's not any specific quantity, right? So it works in both ways. It is of no specific quantity, which means it can't be used to denote some specific quantity, like how far Sarah walked.
So, the way, so omega is a specific quantity in the sense that it differs from its neighbors in a well-defined way. Now, when you say it's a non-specific quantity, I assume that means you can't write it in digits. And in mathematics, this is perfectly fine because there can be numbers that can't be written with our digits that can be larger than the digits. So, so can you elaborate on what you mean by specific, Riley? Yeah, I think that would help.
Sure. So the way we get to numbers normally in philosophy is we would say, here is one tree. I can see one tree here. And then you see another tree. It's like, oh, this is one more than the one tree I had before. That's the concept too. And so on and so forth. And then you can build out all the natural numbers. And from the natural numbers, you can build the rational numbers by taking ratios between them, right? And then you can build the real numbers beyond that, right? It's you can build this number system up but you build it up from actual observations, right? You notice that we didn't just sit in a blank room and then go, eureka, the number pi, and then think for a little longer, the eureka, the square root of 2, right? That isn't how we came to these, to understand these things, right? So for anything we observe in nature, it has to be limited, specific. It is what it is, right? Not anything else. This is the law of identity, one of the most fundamental, in fact, in a certain way of looking at it, the most fundamental axiom in all of philosophy, right? So, because anything is what it is, because A is A, it is limited in its attributes, in the magnitude of those attributes, in the quantity of whatever, how much you got, right? It has to be limited. You can never be walking along and then see, oh, look, there's infinity trees. Like, that doesn't make any sense. That could never, ever, ever happen. So then, how do you get to the concept of an actual infinity, which you're denoting as omega? Like, what actually is omega here? What does that refer to? Like, can I go along and see omega trees? Like, what would that mean?
So it is a symbol, right? And when we use it in mathematics, it would mean we had a omega number line, and we could maybe zoom out, but maybe we could say omega meters, and then we can zoom out omega far, and then we can see, oh, that's an omega meters, right? And that would be just using basic multiplication and division, right? Of course, we can't use our eyes to see this, and that's why it's still a potential, right? And I agree it's a potential, in that I can't prove it with eyes. But the cool thing is omega does hold identity, even if it's a symbol. And it does follow mathematical properties like any other number, any real number, actually. And I could link some Wikipedia articles I've read, although Wikipedia, I think, I've read enough to understand it enough. And so I would call these a specific quantity, in that you can see where you are in space if you were at, let's say, omega distance far from Earth, right? You can still look around you and you can move around left and right, and the coordinate system would still be fine.
Right.
So, but
Sorry,
I understand your position. I understand your position is that omegas can't exist, and that's what I have problems with, because saying they can't exist would require you to somehow prove their identity is wrong, like they can't hold identity, right?
Right, so I don't know what it means to say I am currently omega meters away from Earth. Like, based on what you've told me about omega here, like if I said, oh well, gloop, that's just a symbol for something, and it's fine to use this symbol gloop, and gloop has identity because we can have a gloop number line, and if you're in space and you're gloop meters far from Earth, you can still look around and understand where you are. Like, but what is gloop? Right? That's the problem I'm getting at here. Like, what actually is omega referring to?
Right. Now, omega is a distance, a defined distance. Now, you would have to show that, or let me think. So, numbers aren't gloop. Can you explain why numbers specifically aren't gloop? Is that because you can like observe a 1 meter long thing?
It's that I haven't actually told you what gloop is there. Like, I've just said, oh, it's a symbol, and you can be gloop meters away from something, and we can have a gloop number line, and it can be gloop meters from Earth, but like, what is gloop?
Right. Yeah, this is where I've been stuck sometimes, right? In my discussions with some other people, actually, where I don't make progress from this point because I don't understand how to navigate out of gloop. But the question I would have is, wouldn't it be what's it called? Like, omega is well defined with logic, and I could send a link for that. Whereas, so it doesn't it doesn't bring about any contradictions, and as far as I understand, that would mean it wasn't gloop, right? Because it would have well-defined properties that, just abstractions, of course, not an actual thing. But it would be like a number, like as abstract as, let's say, a 2, right?
Well, it's like,
So my question, sorry.
you know, like, I distrust that well defined with logic is actually referring to the same thing that an Aristotelian or an objectivist would mean when they're speaking of logic. Because logic has been taken in modern mathematics to basically just be an arbitrary game of symbol manipulation where you can come up with whatever rules you want, and you can allow contradictions if you want, and you can disallow them if you want, and it's all just arbitrary. Like, so I don't know, like, how specifically is gloop being defined with logic? Like, what is not gloop, like, what is omega, right? Like, I'm saying, currently omega seems to be the same status as gloop. Like, I can define all these random properties of gloop and say gloop plus 1 is greater than gloop, and you can have a gloop number line, and you can be gloop meters away from something. But like, if I came up to you and said I'm gloop meters away from something, you'd rightly say, well, how far away is that?
Right. But it's still a specific amount. It's just that you can't see it. So if you like, as again I said, you can zoom out. Again, I guess a gloop amount, right? It's going in circles. Yeah. Um. So. But why? So numbers are not gloop, and let me think. If you'd like to add anything, please do. Maybe it would help me understand.
Sure, I could point out why this line of attack I'm doing wouldn't work on the number 5. Like, if I say I'm 5 meters away from something, and you said, well, what is 5? What does that mean? I could say, well, 5 is this many, right, and point to 5 things. This many is 5. 5 is 1 more than 4, and 4 is 1 more than 3. You know, you can define it by succession, right? And I'm actually referring this concept I've got, this number 5, to actual things that I can observe. Right? I'm actually relating it back to reality. But I don't see the relation between gloop or omega and reality. Like, I don't know what the relationship is. So if somebody says they're omega meters away from something, I have no clue what they're talking about.
So if somebody, like, if I say I'm trillion meters away from Earth, that would not be gloop because I can define it recursively with my definitions of 1 and adding 1, right?
Yeah.
With the same reasoning, I would be able to define omega. This would be pretty difficult, but like, okay, I don't know if it's allowed to say that in discussion that I know it's possible because I don't know how to do it off the top of my head, right? I would need to Google a bit. But as far as I understand it, right, if you're allowed to talk about these numbers and you're allowed to do operations on them to extend their logical extend their definitions by making a number arbitrarily large, you would be able to define omega with by saying it's larger than any number, but still specific amount. It wouldn't be able to be written with digits because it's larger than all of that, right? But like
I think saying
you can logically.
Oh, sorry, go ahead.
You can logically extend numbers, but I don't know where the limits are with doing that, you know?
Sure. So I think the working definition we have here of omega, that it's larger than any number, but it's still a specific amount, that just on its face sounds like a contradiction to me, right? Because if it's a specific amount, then it's some specific number, right? Some specific quantity. But it's supposed to be larger than any specific quantity. So it couldn't be. Like, if A is greater than B, then A isn't B, right? So if omega is larger than any number n, then it couldn't be any specific number n, right? I could take n to be arbitrarily high, and omega is still going to be larger than it. So it can't be any number n.
I should clarify. So when I said a number there, I meant the real numbers. The real numbers can be written with digits that we have in our normal notation, right? So we have 10.538, and then we can go on, right? And we can write a decimal that is, or it's called decimal, a number that's pretty large, right? But when in your definition of a number that you're mentioning here, I think you're including omega in your number system. We could count omega as a number, but I wouldn't say it's the normal number that we use every day, right? But you could count it as a number if you would want to with saying this, because when you say is over n, right? When I say n, it means every real number, every number we can write with our what's it called? With our digits. Uh, but these are over all of those numbers, which would be the set of real numbers, right? And omega is just bigger than that. An
Right.
extension.
But I don't know how it can be that you can have bigger than any real number. Like, I don't know. Like, I know how real numbers are constructed and how they correspond to reality. Like, I've seen, a stick which is 3.2 meters long. The square root of 2 is irrational, so it can't even be written as a ratio between two things, right? Like, or two whole numbers rather. It can be written as a ratio between things. But like, I don't know what the correspondence between this thing omega, which is bigger than any real number, but it still has a quantity. Like, any quantity I've ever seen has been a real number. Like, I don't understand what this even
Exactly
means to
right.
say that this has a quantity.
I don't think it can. So it should be able to be explained in words. I don't know if my skill is good enough to explain it in beautifully. But I can try explaining it in this way. So you know how you can walk half a distance in half a second, and you can walk a quarter of a distance in a quarter of a second, and you can walk an eighth of a distance in an eighth of a second, and then you can do this infinite amount of times, yet you can still do it, right? You can still walk 1 meter.
Okay, so this is like Zeno's paradox.
It's
Like, you walk halfway and then you walk a quarter, and so on and so forth.
mhm.
Right.
This would tend toward infinity, uh, and you would hit every what's it called? You would hit every specific amount, yet it still ends, right? It still like finishes. You can describe a really short amount, shorter than any normal number, so that means real number, as this epsilon, which is 1 over omega, right? Of course, you can define it as this. I guess you wouldn't know where you would begin, but this epsilon would then be maybe epsilon plus 10 or something, and it would still, the mathematics would still work out here. You give it a number, and then you can do normal math with this, and then you can round up to the nearest normal number, which would then give you the actual result of this long, tedious, infinite process, right? So
Sure.
in that kind of sense, you can actually use it to solve equations and give a real number result. So technically, it should have been a infinitesimal result because you did approximate the infinitesimal, right? But it still gives an actual result if you round. Well, sorry, it gives a real number result if you round, yeah.
So, like, I don't think you need any reference to the concept of a limit or anything like that to resolve Zeno's paradox. I think for Zeno's paradox, where how does the man walk across the room because he's first got to walk halfway, he's got to walk a quarter, and then an eighth, and so on and so forth, that is using infinity as an actual there. So he's saying there are actually infinite subdivisions between any point A and any point B, and you've got to go through all of them before you can get to B. This is incorrect, and this is what Aristotle noted. Basically all he's saying is, I can continually subdivide this line forever. I could keep having it, and then having it, and then having it, and so on and so forth. But that is describing a potential. Zeno could go about this task of continually listing off smaller and smaller and smaller fractions, but those fractions aren't actual unless and until he gets to them in his process of listing, right? So you don't need any limits or anything like that. And wherever in mathematics I see any sort of reference to infinity like this, I'm immediately incredibly suspicious that they have not learned the lesson that Aristotle was trying to teach them here.
And the reason infinity can be scary is because it doesn't have it doesn't follow mathematical properties, right? And now that I think about it, I think I was wrong. So when I said you pick an infinitesimal, right, it still wouldn't reach in the what's it called, the undefined infinity that you're talking about, right? It would reach beyond our numbers, but it reaches this infinitesimal, and it's still less than the infinity that we call the quote unquote like the end, like somehow. That's again why it's so weird. But let me think. I lost my train of thought. So we use it as a rounding tool to round to the nearest number that we use in our normal use, right? So I can say with confidence that these omegas are larger than our numbers because we can use them and then round them to the nearest normal number that we're used to. It's useful because they're larger, right? They aren't the actual infinity that you speak of, though, because they have a length, as in, sorry, they have a specified value. You know, they are less than this because, you know, omega plus 1 is still bigger than omega, right?
But like, what I'm not getting is how this is actually, like, I don't think the mathematicians who came up with omega and made these rules for it such that you can actually like keep doing equations on it and stuff like that. I don't think they at any point related this concept to reality. Like, I don't think that they looked out into reality to get to their concept of omega. I think they made the rationalist error of kind of retreating into their minds and trying to come up with new knowledge through some mystic revelation rather than actually looking out at existence.
Mm-hmm. No, I agree. I think this is you come up with this idea, right? And that's why we can't call it an actual. But the wording you used in your article was no infinity can exist, right? And it feels to me like you know this omega can't exist. And if the mathematics works out and there's no problem with the identity, and I do retreat into my head when it comes to this, right? I just um how can you know it can't exist, right? But yeah, you call it gloop, right? And I'm not sure how to not make it gloop. I guess I would have to give the entire logical reasoning for it, maybe. But like, do
So
you understand my train of thought here?
somewhat. You said there if the mathematics works out and there is no problem with this thing having an identity. I think there is a problem with this thing having identity because a potential doesn't have identity. A potential doesn't actually exist yet, right? It's referring to something that's off. It's not here yet. It's not actual. The actual has identity, not the potential, right? So because this doesn't have identity, the mathematics can't work out. Now, what I mean by this is mathematics, its task is that it is the science of measurement, right? And you have to be measuring something in reality for what you're doing to be actually classed properly as mathematics. Now, the modern mathematician, in many instances, has completely abandoned his task here and has just gone into these rationalistic chains of deductions from arbitrarily selected rules that don't actually correspond to reality in any sort of way.
So since you haven't seen a billion things, maybe a billion is a bit small. Well, let's say you haven't seen a quintillion. Will that then be a number that again, you can define it, you can extend your understanding of the numbers by doing +1 all the time, right? But isn't that still creeping into your head, or what? What do you think?
No, I don't think, even if it's a very big number, I don't think it's making the same error of retreating into your head. Because you can relate quintillion to actual observations, you can relate it to actual things you're encountering in reality. And maybe there are certain problems, which I don't know about, where you do need to go up to a quintillion to properly capture with the proper degree of precision what you're talking about. Like maybe that's a thing, right? And then that would be an actual quintillion. So quintillion wouldn't be a floating abstraction there. But I see absolutely no, like, because I've built quintillion off of the observations that I've made of things, right? But I don't see any way to build omega out of observations of things. Because based on what you've said to me, it's like, well, this is bigger than any real number, which should already like be throwing off red flags. But it still has a quantity. But like, what in nature has this property where it's bigger than any real number? Its quantity is larger than any real number, but it still has some specific quantity.
Mm-hmm. I understand your predicament, or the predicament. But so when you say infinity can't exist, would you then not need to prove that it is gloop, or what?
So the way I prove, or rather Aristotle proved, that there can be an actual infinity, like, so to be clear, I think that there can be a potential. You can treat infinity as a potential, and you can validly say there are infinite numbers, there are infinite conversations we could have here, like etc. etc. But treating it as an actual, the reason why that could never ever ever come about, no matter what, is because infinity means larger than any specific quantity. So it can't be of any specific quantity because it's larger than all of them. But if it's of no specific quantity, and you're treating it as a quantity, which you have to do if you're treating it as an actual, then it's a quantity without identity, right? But A is A, and existence is identity. So if it doesn't have identity, it doesn't exist.
Yeah, and that definition of infinity isn't omega, right? That one is larger than omega, or if it existed, I guess. So the definition is larger than a specific quantity, but I think the specific quantity in this case would be including omega, since omega is a specific quantity, right? But it's still referred to as an infinity in most respects because it is larger than any number you can write with a decimal, right?
Right, but which specific quantity is omega?
Right. Which specific quantity would be omega? You have to have a reference point, right? Or is that what you're asking for?
Yeah, like how are we relating this to reality? Because like the thrust of the article is that if you can't relate something to reality, then it's what is called a floating abstraction. It's an abstraction without any concrete referent. So like, what is the concrete referent of this quantity omega?
So, yeah, so I think we're going in a circle and like kind of. I'm still confused on this proof of Aristotle you used that to disprove any infinity existing, right? But since omega isn't that infinity, do you think omega would be a quote-unquote not infinity that could exist theoretically if maybe in a future world where we build whatever science, blah, blah, blah.
So I don't see any reason to expect that there could ever be a quantity greater than any real quantity. Real in the specific mathematical sense there. I don't know what that would mean. So this is sort of related to a different error in epistemology called Cartesian doubt, where basically it's like, the way he used it is somebody gives an argument, it's like, well, you could have made an error there. Man is capable of making errors after all. So how do you know that for sure? Because you could have made an error. So this is an invalid way of doing epistemology. It is inverting the burden of proof. Because specifically, I can't point to the non-existence of error in some claim. So here, I can't point to the non-existence of a quantity greater than any real quantity. Like that's because I can't point to something that doesn't exist, right? So it's what I describe as an epistemic null statement. That is the category that omega is under, as far as I can tell, right? It's just asserting that, well, what if there could be this quantity greater than any real quantity? But like, that is of the same category of claims as me saying glip de glap, de blah blah blah, right? Just gibberish, right? Is that true or false, right? The glip de glap, blah blah blah, is that true or false? Like, it doesn't make sense. Like, I can't answer that. There's nothing to unpack there. Omega is in the same case there.
See, so you mentioned Cartesian doubt, and I have heard a bit about it, right? But I think it's the other way around with this, because if I assert that but let me think. That's a bad analogy. What I'm saying is that when you assert that there can be no infinities, then I would give a counterexample, and if that counterexample doesn't follow through your argument, right, then the argument doesn't rule out this kind of quote unquote infinity, not the actual infinity kind of type that Aristotle talked about, right? And so sure, you could relate it to Aristotle doubt, but isn't it like only if okay, our Cartesian doubt. Can you explain our Cartesian doubt one more time to me? Because I forgot. Sorry.
Sure. So it's basically, it is taking doubt as, or error as being more primary than truth. So it is saying, somebody gives some argument like, all men are mortal, Socrates is a man, therefore Socrates is mortal, right? And then the Cartesian comes up, and he says, yes, all well and good, but you might have made an error there. So how can you be sure in your conclusion? How can you know that for certain, right? And then the rational man would say, well, you know, it's not on me to point to the non-existence of an error in my statement. Like, I can't do that. The burden is on the Cartesian to say, hey, here's some specific error you made in your deduction that Socrates is mortal. Like, because for one, you can't point to things that don't exist. Can't do it. You can't point to the non-existence of something. So I can't point to the non-existence of an error in my claim. And second, it's a stolen concept fallacy. So what they're doing there is saying, well, because man can error, therefore we have to discard everything. Everything's an error, right? But that, you can't have that, because how do you get to the concept error? Well, you have to first have the concept truth. And an error is any deviation from truth. So they've stolen the concept of error whilst denying its genetic root there. So this is just a wholly invalid way of going about epistemology.
Mhm. Okay, so what you're saying is when I propose omega, this is gloop, and when I put it to the test, put it through your test, I'm saying, or when I'm attesting that this is an infinity, then um, you would um, you would say that that wasn't that you would say that that's gloop. So it isn't a what's it called? It isn't a valid argument against it. So it would be similar in the sense that it would uh, not be of value to know the truth, something like that.
It's sort of like the burden is on the mathematician to relate his concept omega to reality. Like the burden isn't on me to show that there's no possible way for omega to relate to reality. I think I've already basically done that because I think it's floating abstraction, right? The burden is on him to say, well, no, your argument against infinity, it has this specific error which doesn't, and it therefore can't account for the case of omega, right? Until like it's not on me to point to the non-error in my claim. Like it's on the mathematician to say, hey, you've made this specific argument here, which doesn't account for omega because he reasons X, Y, Z.
You asserted there is no uh you asserted there is no infinity that has identity, and then used an argument that works for infinities that are not these kinds that I'm talking about, right? So, okay, can I just okay, important question then. So, would you count omega as an infinity? Right, that should be important.
Well, it certainly sounds like infinity to me because I think any quantity is a real quantity. I don't think there's any specific quantity that is bigger than any real quantity. And like the burden is on other people to show, hey, no, this is a specific quantity which is bigger than a real quantity, and here's its actual referent in reality.
Mm-hmm. Okay, interesting. So if you would require a referent in reality, then I can't provide that, right? Of course. Um, but okay, so if I said there is no actual one uh quintillion, let's say, right? And would it be you who would have to provide me with an example that there can be one quintillion by getting, let's say, one quintillion coins?
Or I can just, count up to 1 quintillion, or I can say, hey, 1 quintillion can be represented by this equation, right? I can show its relation to reality in that way. And the second I describe this concept, like it is actual, like because I think numbers exist in your head, right? They aren't actually in objects out there. So like, I can give you a number that nobody has ever said before. This number is pure at this moment a potential. It's the number 36754312555555673215555. That nobody's ever said that number before, ever in history, right? I actualized it just then.
Okay, right, that makes sense. Right, cool. And it wouldn't be valid. Wait, so the reason it's valid is because I understand that number system in my head. But since omega is not representable in that number system, then you wouldn't understand it. But if we lived in a realm where we could extend or we could zoom out to omega, then we could see these things. So that's hmm. Hmm. So I'm still thinking like there. I would love to like research this a bit more and send you a proper equation for something like omega. We'll see if I'll be able to do that. Um, if I can relate it to normal numbers, would you then say that okay, infinities can exist uh, that that are well defined with identity, right? Or
Well,
what? Right?
if you could somehow relate this omega number system to reality and show, hey, there can be specific quantities which are bigger than any real quantity, then I would no longer class omega as an infinity, right? That would be what would change, and then yeah, my argument wouldn't apply to it anymore. But I do count it as an infinity, right, because I don't think there could ever be a quantity greater than any real quantity.
So I think the only thing we differ on then is whether these omega class numbers are well defined. And I would say, since I've studied them, so okay, interesting. This is great because this means that I understand your position perfectly. I think, it's still okay. So, but wouldn't that mean no? This is Cartesian dot. The Cartesian dot came in. Okay, now I get it. Right. Okay, I get it. This makes sense.
Cool.
Okay. Cool. So yeah, okay, that makes sense. I think I'm good. Like I understand it. I think is it like my head exploded.
Yeah. Yeah. You tried to store infinity things. So
the only thing we differ on is. So the only thing we differ on is whether omega is natural infinity or if it's if it's the infinity that we class as non-specific or the infinity that we class as specific. I'm asserting it's specific, but you're saying that's gloop because I can't explain it properly. Perfect.
Yeah.
I think I can agree. And lovely.
Cool. Yeah, it was great talking to you.
Is there anything you want to talk about else? Like anything? Yeah.
Kind of think. I know you did have like a list of things you wanted to go over. I suppose we can get back to that in DMs because I've only got until the end of the hour, and we can like discuss them at another time. But yeah, it was great having you on.
Yeah, thank you. It was lovely. I loved the conversation.
Yeah, and I'm gonna be doing like until the end of the hour. I'm gonna be in the Discord, VC. I think you're in the Discord, right?
Yes.
Yeah, we can chat in there afterwards if you want. Yeah, I'll see you in a bit. Then.
I'll be down, or I'm down.
Yeah, cool.
Yeah.
See ya.
That's fun. Bye.
Then let's go down to here. Let's go down to here. Pardon me. Invite people to. Yo.
Lovely. That was very fun. I thought those would be way more stressful. I did notice I was stopping a lot, but I hope that's fine.
Yeah, that's fine. That's fine. All right. Lovely. Just putting the link into the chat and whatnot. All right. To be clear, I'm still streaming this. I don't know if I explained that well enough.
I didn't know that. Now I know, so that's good.
Let's go. W, absolute W.
Complete Zulu W yet again.
I think we both got, or at least, yeah, I think I understand the position a lot better now.
Mm-hmm.
Yeah. I mean,
a question that I'm not sure I know how to even articulate. If so, I'm going to try my best here. If you were to try and notate infinity with actual numbers, it would have to reference itself, which we don't know what that is in the first place, right? Maybe there's a better way of asking that, but does that make sense?
It does make sense. And as far as I understand it, you can't represent it with normal operations, since no matter how big you get, you won't get to omega. But I know that omega can't be properly defined, so I'm really curious. And that's the equation I wanted to send Zulu if I research it more. I don't think it's represent. I don't think it's representative.
I would recommend you should there's of course there's the book like OPAR, and there's the lecture series that Leonard Peikoff has. He really explains it well. Like it's not that, when we say that infinity is not real, we say that we cannot point to a physical object that is infinite. That is not to say that we cannot have a concept of infinity, because imagine how the first person who came up with infinity came about it. He would have thought that, okay, in reality, I can count to a certain objects, but if I just think about this, there can always be one more, right?
Mhm.
So that's the concept of, that's the beginning of like the Aleph Null, the simplest concept of infinity that we have. But that's what you must remember. It's a concept. There's like, it's not out there. It cannot be out there, right?
You can't reach omega by counting.
Yeah, you cannot. But like that's the thing. Like if you just like continue to do so forever, like you imagine someone, like that's the thing. You cannot actually do it. But like
Right.
you can imagine if you did. And
Right.
that's the key concept there is imagine. Therefore, that's human cognition. That's human consciousness. That's a concept.
Yeah, like and
Therefore,
this.
it's not real in the terms of.
Oh, sorry.
Yeah,
Sorry.
go ahead.
Yeah, like man is completely correct. Like this also ties into the objectivist theory of like the problem of universals, like which is basically just where are universals, where are concepts, like so Plato thought they were in like some other world up in heaven or whatever, the world of forms. Aristotle thought there was like a universal element and an individuating element in each individual things. So like concepts refer to the universal element, but he's wrong there. Objectivism rejects that. They are, as man was saying, like just in your head, right? This is the objectivist view. You, in your mind, you abstract away from the particulars. You omit the measurements is the technical term, and I've got like articles on the on how objectivists think concepts are formed. Like, yeah, like concepts aren't actually out there ever.
That's why they're concepts. Yeah, and like I was like playing with some of these. I think it was a Kantian person. He was, or Platonist. He was saying that they are immaterial objects. So I was like playing with him. Like, can you point to like long division and multiplication going on a date or something? Like, so that's the thing. These like they have to invent like whole ass different dimensions to explain something that's so simple as human cognition. This is just how our brain works. We're smart people. We have figured out ways to make our job easier, and like we have a conceptual faculty who can do these things. It's our nature. Like we cannot point to like long division handing out with multiplication. They're concepts. They're not precepts. They don't exist.
And that is actually like the original meaning of Occam's razor. Like Occam's razor is just kind of thrown around all over the place. It's just like, oh yeah, that's a little too complicated. So Occam's razor is invalid. It's like, no, that's not what Occam meant by it. Occam stated the principle as don't multiply entities beyond necessity. And you see this all over the place. Like Plato invented a whole other dimension to explain what is just right in front of us. So he's multiplying entities beyond necessity there. The beyond necessity is, of course, doing a lot of heavy lifting. And it takes a whole theory of epistemology to know what beyond necessity means, like what the standard of that is. But yeah, like this is all over the place.
Yeah, that's the thing. Like once you see it, like once you like read through objectivism, it's like just that it was so simple. Why couldn't they see it? But yeah, we have to remember they did not have the internet. They did not have like a lot of this. So like, yeah.
I remember like I remember the first time I read Opar. Like for basically my whole life, I just considered philosophy just like a bunch of nonsense. And I was just like, well, why would anybody ever want to do philosophy? Because I just conflated philosophy with like just the absolute nonsense I was hearing because I live in Kant's inherited world, right? So I just wrote off philosophy completely. I was like, no, I don't want to do anything philosophy. I actually want to study what's actually existing out there, That's why I was interested in like, physics and mathematics and stuff. I want to get down to like what is fundamental, what is actually there.
Physics and mathematics and everything,
And then I start reading Opar, Objectivism and Philosophy of Iran, and I'm just nodding the whole time, like, yes, finally. Somebody's saying it right.
Yes, like it's so right.
What would be
and the point you get to politics
saying that matter will exist for an infinite amount of time, or is there an error there?
Well,
the problem there is an infinite amount of time.
Yeah.
Time is a relational quantity. Like we cannot define time in an absolute. For example, like 1 second is how much light travels in 1 by 3.2.9979 into 10 to the power 8, or like 1 day is how much an Earth rotates.
There's a,
Like
or
one,
shorter. There's a 0 point.
There is
Yeah.
so like
effectively, yeah.
the universe, basically the way it's described in objectivism is the universe is eternal, and I think Aristotle agrees with this. Like there wasn't a first moment of time. Like there wasn't a first instant. Like that doesn't make any sense because, you know, man was explaining it like it's relating motion.
Okay. So
Didn't they find that these decay events?
Can I get some clarification on, like, if we were to measure, because time, I think you just said it too, but like time is the measurement of movement. So if we were to measure the movement of a rock, well, I guess we couldn't technically do what I'm about to say, but where is the error in saying that, like, tracing the movement of that rock, words, can go on infinitely?
So you that is
Because
fine because it's describing
you
a
and I-
potential. Like you could keep tracing this rock
You could.
forever, right? Like, but you'd never get to the end of forever. Like you could just keep tracing its motion, right? And like so, I want to sort of elaborate on this. The universe is eternal stance. Like that kind of confuses people, like because they, you know, it seems intuitive that, well, there must have been. How did we get through all of the previous time, all of the previous eternal time to get to today, right? I think I classify that as being the same. I think this is Peikoff's example of I hold up my finger and I say, how much distance is there to this finger and how did I travel all of that distance to get my finger here? It's like, well, distance from where, right? So my distance between my finger and the Eiffel Tower, and like which route are we taking? Like it's all the same for time. Like how much time has there been up to date from what point in the past and through what route? Because, you know, we know from philosophy that time's local, and we know from physics that time is relative. Like your clock can slow down, speed up and stuff. So like how much time has there been until today since January 1st, 1970 in the middle of a black hole? Like that's a very different question, right?
Yeah. Yes. And another thing, like a lot of people make this fallacy that they think that the Big Bang is where the universe started. I think that's just a bad definition of the universe. Like the universe, like, you know, in set theory, which is actually set theory and objectivism share a lot, and so does relational algebra. Like I'm studying a lot of computer science, so I'm noticing parallels everywhere. So, you know, like in set theory, a universal set is whatever there is. So
I
at the
believe
Big Bang, you know, the Big Bang was a big expansion of whatever there was. There were still things before that. It's just that
I believe that
current laws of physics can't do that.
when people talk about the Big Bang, they're not necessarily saying that reality started with the Big Bang. Just the way in which the universe is organized as we speak, the
Yeah, but a lot
observable
of
universe,
people do say,
the result.
yeah. I mean,
Big Bang.
It would appear
with
that,
that, I
like,
agree.
theists often frame it that way against atheists.
I mean, that's the thing. Like, when we talk about the universe, we should think about it as the universal set, as whatever there was, you know? And in that concept, like, there cannot be any time. You can say that from the Big Bang, this amount of time can be, you know, reasonably assumed to have passed, but you cannot say that that was all the time in and that's how old the universe is, because universal sets are all there is, and clearly there was something before the Big Bang because something exists. Go ahead.
No, sorry, I was just going to wrap up because getting close to the end of the hour. But yeah, thank you everyone for coming on. Thank you, Brian, for making a good show of it. Yeah, well,
Thank you. Thank you for that time. It was very fun.
No worries. Yeah, I'll see you guys tomorrow. Actually, we've got a debate tomorrow at the same time as this one.
Yes.
I'll see ya.
Yep. See you.